Hey, happy Friday to you guys. For those of you hopefully watching today, this is a Friday. And so I know for my third and sixth period, this is going to be a brand new day for you guys. For my fourth and fifth, hopefully we've worked through these together. But if you missed it or you lost your stuff, here's a way for you to get this back. So, important thing here is our topic today. So we're dealing with slope and rates of change. Hey, continued. So this is going to be a mastery day. This day is going to be all about mastering slope basics. Kind of the basics of slope is what today is going to be all about mastering. So let's do some quick reminders here. We know there are four kinds of slope. You've got a positive slope. Remember, we read left to right. So as we go left to right, we see that it's going up. Our line's sliding up at a constant rate. Remember, slope is constant. Your line should stay the way it is the whole time. So check it out. A line with a negative slope slants downward from left to right. So it's consistently going down at the same angle. Now, a line with a slope of 0 is horizontal, is what that says. So a line, sorry, it cut off. A line with a slope of 0 is horizontal. It's a flat line. Yep. So it's got a slope of 0, and again, left to right. And then finally, a line with an undefined slope, sometimes we represent that with a 0 with a slash through it, is a vertical line. Okay? And so guys, if you ever get confused as to how to find the slope and you're given graphs, pro tip. Pick 2 points to start. Number one, pick 2 points. So we got to see where the line perfectly hits, where these cross looks like there. Oh, wow, we have several. There. Yeah, we got a few of these guys. And then 2, again, go from left point to right point. I can't stress that enough, guys. Go from the left point to the right point. So, for example, I'll start with this point right here. Remember, we're going to use rise over run. So we go from this point to, I'll go to this point. So do we go up or down first? Oh, we go down. And if you go down, how many? 1, 2. So down 2, and then we go right 1. And if you don't know what that looks like as slope, down 2, right 1. If you go down, that's a negative. If you go right, that's a positive. So negative 2 over 1, which is really just negative 2. Try it again for me on number 2 here. Point there. I'll pick these 2. But again, there's also this point. You got 3 points you can choose from. I'll start with this point in the middle. I'm going to go from here to here. So I go up 1. So that's positive. If you go up, that's positive. And you can just kind of tell, too, by looking at this line, it's going to be a positive slope. We're going uphill. Up 1, and then over 1, 2, 3 to the right, which is positive. So slope of 1/3. I'm going to let you guys try number 3 for me. Number 3 is pretty quick and easy, isn't it? Vertical line, we know that's undefined slope. So what I really like is I like to see how we deal with slope in the real world. See rate of change? Remember, guys, that's just slope. It's slope in the real world. So check it out. Let's say we have a plant. We got a plant that's growing from 1.4 meters to 1.6 meters in 1 year. Well, what would be the rate of change there? We always like to do this in 1 unit of measure. So in 1 year, I like that. How much did it grow in 1 year? From 1.4 meters to 1.6 meters. Oh, isn't that 0.2 meters? So it grew 0.2 meters per year. We have to do it per 1 unit of measure. So 0.2 meters per year. How about number 5? We got a plant that is growing 22.4 millimeters in 14 seconds. That's kind of vague, right? I can't get a good measure of how fast that actually is. Why don't we find out? Let's find out per second. Let's see if we can find out per second. Well, how would we find that out? Well, to find the rate of change, oftentimes that involves dividing. Yeah, dividing. So check it out. We take 22.44 or 0.4, and let's divide that by 14 seconds. If that's how fast it's growing in 14 seconds, let's divide that much by 14. And when you do that, 22.4 divided by 14, I got 1.6. That's 1.6 millimeters per second. Nice. So check this out, guys. This is where number 6 and 7, this is where things get a little dicey. They get a little tricky here. We got the cost of 4 movie tickets is $30. The cost of 7 tickets is $52.50. Now, if you wanted to, we could say, okay, that's 4 movie tickets is X1, 30 movie tickets for $30 would be the Y1 that goes with that many tickets. 7 tickets is X2, $52.50, that's the price, that's Y2 that goes with that. And you could do your slope formula, right? We could do slope equals Y2 minus Y1 over X2 minus X1. You could do that. Here's X1, here's Y1, here's X2, there's Y2. But we don't need to, guys. These are rates. So let's find out how much it costs per ticket. And if this cost per ticket and this cost per ticket are the same, we know we have our slope. So let's do 30 divided by 4, and let's do 52.50 divided by 7. Let's see what we get here, guys. 30 divided by 4, 52.50 divided by 7. So 30. Okay. I got 7.5, so $7.50 per ticket. And then over here, 52.50 divided by 7. Hey, it's the same. Remember, guys, we said slope. Slope is constant. So no matter where we're looking at, no matter how many tickets we buy, they always cost the same. So $7.50 per ticket. Nice. Okay. Now, I'm thinking number 7. We're going to see why. But I'm thinking we're probably going to need to use our slope formula for number 7. Check it out. 5 seconds after jumping out of this plane, a skydiver is 10,000 feet above the grounds. After 30 seconds, they are 3,750 feet above the ground. So we got a dude who is falling out of this plane. Hopefully he's got a parachute, right? So he's falling, he's a skydiver, he's going towards the ground. So I'm thinking 5 seconds after, we know time is always X. So 5 seconds after, he's at 10,000 feet. And we know 30 seconds after, he's at 3,750 feet. Isn't this really just X1, Y1, X2, Y2? Here's the time with the height. Here's the time with the height. Yeah, so guys, we can just use our slope formula. We take a Y2. Our slope's going to be 3,750 minus 10,000 over 30 minus 5. And let's see what we get here, guys. Do the math. 3,750 minus 10,000, negative 6,250 over 25. And then that will absolutely reduce. Divide that. Negative 6,250 divided by 25. Hey, negative 250. So how would you interpret that, guys? That means, this is insane. dude or chick is falling 250 feet per second. That is insane. This dude is falling 250 feet per second. And so that would be our slope here. And again, this is a throwback. I'll let you guys try number 8 for me. But go ahead and pause the video. This will be one we'll check real quick. I'm not going to actually go through and explain because this is just doing what we literally did on number 7, except they already give us the points. So try number 8 real quick. We'll check it, and then we'll move right on. First thing you should always do, label x1, y1, x2, y2. We plug this into our slope formula. We know y2 minus y1 over x2 minus x1. You get negative 6 over negative 4. Hey, a negative divided by negative is a positive. And 6 over 4 will reduce down to 3 over 2 for our slope there. So last page, guys. Not much left on this one. I just want to look at a couple things here. Let's talk real quick about why is the slope of a vertical line always undefined? Why, huh? Well, let's pick 2 points here on an imaginary vertical line. I'm going to pick, let's say 2, 4, and then if we're on a vertical line, we know we're not going left or right, so what's going to stay the same? Oh, the x. Yeah, x is still 2. We didn't go left or right at all, but y is going to be lower. Let's call that 2. So we got 2, 4, and 2, 2. Well, let's find out why. We know slope formula is y2 minus y1 over x2 minus x1. So here's x1, y1, x2, y2. So x1, y1, x2, y2. So we got 2 minus 4 over 2 minus 2. And again, we got those from x1, y1, x2, y2. Watch what happens, guys, when we try to find this slope. 2 minus 4, negative 2. Okay, nothing crazy there. Oh, shoot. 2 minus 2, that's 0. And guys, you can't divide by 0. Can't do it. The universe will explode if you divide by 0. That is why a vertical line is always undefined. If there is no change in x, then we cannot find the slope. Yep. And so last thing, guys, for some of you, this is going to be the toughest part of the day. Some of us have not seen this yet. This may be the toughest part of the day for some of us. So check this out. We're given the slope. We know the slope. But what happens whenever we're missing coordinates? Well, when that happens, we got to use algebra to find them. This is algebra, right? Let's use some algebra to find them. So we know we've got y2 minus y1 over x2 minus x1. I'll rewrite that. So here's x1, y1, x2, y2. And we know slope. We already got the slope. So we know m is not going to be m. It's going to be negative 2 equals y2, 8 minus 4 over x2 minus x1, x minus 2. So first thing, guys, before you panic, let's do the easy math here. What's 8 minus 4 going to be? Oh, that's going to be 4 over x minus 2. And this is probably the part that's going to get some people stuck here. We're going to get a little confuzzled. So take a second, guys. Think about how we can do this. If you have a fraction, we usually like to multiply to destroy fractions. Here's a little pro tip. If you ever have a fraction equals a number, and it's a fraction that has multiple numbers in the bottom, let's create a fraction on the left. What's negative 2 actually as a fraction? Oh, we could just put a 1 under it, couldn't we? Yeah, absolutely you could. So negative 2 over 1 is now a fraction. And we can now, going back to multiply, we can cross multiply. Anybody remember cross multiplying? So you may have seen it as the butterfly method. So we multiply the top here to the bottom there, and the bottom there to the top up here. So 1 times 4 gives you 4. Here's the tricky part. Equals negative 2 times, two things down there. So negative 2 times x minus 2. We've got to multiply that to both of those. Okay? So that means we're going to be distributing. Hey, and guys, this is a normal equation. This is like a 2-stepper, 3-stepper. We can solve this. Distribute. 4 equals negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Subtract 4 over. 4 minus 4, 0. And then it doesn't matter what we divide 0 by. X will always be 0. So you got it there. X will always be 0. How about let's do one more here. Let's do one that's I think a little bit easier. Check it out. Part C. I like this one. So again, here's our m. x1, y1, x2, y2. Okay? So m equals, so 2/3 equals y2 minus, oh shoot, y1's already a negative. What's that going to mean? Means that becomes plus over x2, it's a plus, so x minus 4. I'm going to see if you guys, after we add, of course, 10 plus 6 is 16. See if you guys can finish this problem. See if you can finish this problem for me. You can go ahead and pause the video. So check it out, guys. We cross multiply. 3 times 16 is 48 equals 2 times, we got two things here. So 2 times x and 2 times negative 4. We distribute that 2 to both. So 2 times x is 2x. 2 times negative 4 is negative 8. Then we got an equation we absolutely can solve. Add 8 over, gives you 56, equals 2x, then divide by 2, x equals 28. So don't forget, guys, Delta Math for homework. We got that live right now. Go ahead and be working on that for me. Thank you very much. Have a great weekend.